So far we have seen, the five physical quantities related to motion, to describe motion, which is your speed, distance, velocity, displacement, and acceleration. Now, in this video, so far we have understood these two pictures and through some examples. Now, in this video, we will do two things. First, we will try to represent and understand motion in a graphical way on a graph, right? As well as we will derive some useful formulae to generalize all the observations that we have done so far, right? So we'll have two things. We'll try to graphically show them in two kinds of graphs. We will start with what we call as distance time graph, and then we'll go to the velocity time graph. So when you say distance time graph, we'll start with this. When you say distance time graph looks like this in the form where in this graph you have your distance in the y-axis, and then you have your time in the x-axis. Right. So this is your distance time graph. In the velocity time graph, you have something like this. You have your velocity on the y-axis, and then you have your time on the x-axis. So that is how these two graphs work. So let's represent some behavior. Let's try and represent some scenarios that we have gone through on a graph. So let's consider the scenario of a person or an object. An object that is moving along a straight line at a constant speed. Right. Now, how do we represent this on a graph? An object that is moving along a straight line at a constant speed. So when we say an object is moving at a constant speed, what we mean is, if I take this as the origin, for every second, it covers the same amount of distance, right? That's what we mean. So after 1 second, let's say if it covers 1 meter, then after 2 seconds, it should cover 2 meters. After 3 seconds, it should cover 3 meters, and so on, right? So that is how the object would move from its origin, right? Now, how do you represent this as on a graph, on a distance time graph? So on a distance time graph, if this is your distance and this is your time, and if the object was at rest at time 0, right, it should constantly, at time 1, let's say this is time 1, if it covers 1 meter here, so which means that it is here. At time 2, it should cover 2 meters, which it is here, right? And at time 3, it should cover 3 meters, which is this. So if you really plot such a graph, it would look something like this. It would be a straight line, right? It should be a straight line. And that is the behavior. So an object that is moving along a straight line at a constant speed, the distance time graph would look like this. Right? It would look like it would be a straight line when you plot it. Now let's take the example. Let's take another example where the object's speed is not uniform, right? an object that is moving with an that moves. Here also it's moving along the straight line, but with a non-uniform speed. So what this means is that so this particular person. So if I find an equivalent of this, so what will happen is this person after 1 second. Let's put it this way. After 1 second, this person, let's say they cover say 10 meters. And then the second session, in the second second, if they are able to cover 20 meters, right, between A and B is 20 meters, right, and between B and C is going to be 30 meters, right. So their speed increases, right, every second. So this is the first second, this is the second second, this is the third second, right. This is the third second. Now, given this, how do you plot this thing on a distance time graph? So if you really see this, if this is going to be your time, and this is going to be the distance. Now on the first second, it is going to be 10. Let's call this one as 10, right? So this is how the first thing will be, and in the second second, we are saying that this object will be in 20 meters, right? So which means that it will be somewhere here. So it must be something somewhere here, 20. And on the third second, and after 3 seconds, it is able to cover 30 meters, right? So which means that after 3, it will be somewhere like here. So if you really plot this, this is not going to be a straight line. This one is going to be a curve. It is kind of exponentially. It's like an exponential path here, right? So so the distance time graph for an object that moves along the line with a non-uniform speed is going to be a curve. So that's the primary difference. Now, how does this work? How would we plot this? The same thing. So what we have just seen here is a distance time graph. But let's try and find how it would actually work on a velocity time graph, right? Now, on a velocity time graph, let's see. So let's take the velocity time graph for this scenario. We are considering an object that is moving along a straight line at a constant speed. Now, for the purpose of this example, let's say that this object is not backtracking. It is always moving in the straight line, which means that it is not the speed, the magnitude of the velocity and the speed are the same for that object, right? So to be precise, it is the object. It is like the person A. It is this person whom we are considering here. So for this person, the distance covered and the displacement at any point in time will be the same, right? So we will take that as an example for us to plot their behavior on a velocity time graph. So in this scenario, for velocity and time, so we see that this a person who's moving away from for a person who's moving away from the origin. So what you see here is when somebody is moving at a uniform speed, or when somebody is moving at a uniform speed, which means that at every time, right, be it at the first second or the second second or the third second or the fourth second, their speed is going to be uniform. It will be a straight line. It will be a flat line that is going to be parallel to to the x-axis, right? So if they are always covering, if for this example, if they are always covering, if their speed is going to be, 1 meter per second, which means that, and that will remain the same at every point in time. So it will be a straight line that is going to be parallel to the x-axis. Now let's take the example of the second example, an object that moves along a non-uniform with a non-uniform speed, right? Which means that an object, there can be two different things. Whether it is, if it is accelerating, what we saw here is, this object was accelerating, which means that it was the rate of velocity was constant, right? If the rate of change of velocity was constant, right? That's when we say that an object is accelerating at a uniform. That's when we say that the object is undergoing a uniform acceleration, right? So when the acceleration is uniform, how would it be? Which means that in that scenario, your object is you have your velocity and you have your time, right? And in that sense, your velocity would all constantly change at an equal rate, right? So in our example, if I try to plot this one, this example of a person moving from O to A, A to B and B to C, we see that their velocity changed from 1 meter per second to 2 meter per second to 3 meter per second, right? So in that case, if I plot this one, if you try to plot this in our graph, it would be like, after the first time, it will be like 1, 2, and 3, right? So at regular intervals of time, here also it would be a straight line, similar to how you would have seen the other one, right? So this is how it would be a straight line when your velocity, time graph will show a straight line for an object that is having a uniform acceleration. So this is how your uniform acceleration will be. And similarly, when an object is not undergoing a uniform acceleration, it can be at any state, right? So you can have on your velocity time graph can go in any way. If that object is not uniformly accelerating, your graph can be will not be a straight line. So this is a non-uniform acceleration. Okay. So these are the various time graphs, various distance time graphs, and we will, in the next video, we'll go ahead and derive some formulas that are going to be relevant for scenarios that undergo, where an object undergoes uniform acceleration.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share, and subscribe this with your friends. Thank you.